Hi friends, welcome to GMK tutorials. In this video, we are going to see about the pipelining. So before going to the pipelining concept, we will give some recap about the parallel processing. So in case of the parallel processing, area can be reduced to the very small value. It is approximately 0.227 of the original value. As well as, the power dissipation can be reduced to 0.277 of its original value. But the area can be increased to 2.2x, that is discussed in this last video. Let us see the last diagram that shows how the power and area and throughput in case of the parallel processing. So the basic drawback in this parallel processing is nothing but area is also increased. The basic intention of the low power application is nothing but we need to maintain a minimum area, we need to reduce the power dissipation as possible as well as we need to maintain the minimum standard performance of the circuit. That is a basic consideration, right? So for that purpose, how such a kind of the problem can be overcome with the help of a pipelining concepts. So before going to this pipelining concept, just I will requesting all the guys, please subscribe our channel. Still, if you are not subscribing, okay, then it may be helpful for your friends also. So thank you for watching GMK tutorials till now. I will be very thankful to each and everyone who supported me directly or indirectly also. So let's move on to the topic. So pipelining. Generally, what is meant by pipelining? Generally, in case of the computer organization also, you will have some basic idea. Pipelining is nothing but implementation technique which performs the multiple tasks in a parallel manner. Suppose, let it be considered, suppose the T1 work is started, T12, let it be considered, right there, okay, T11. So generally T11 is nothing but fetching, let it be considered, T12 is nothing but decoding. At the decoding of the first instruction, the second instruction is going to be fetched. So I will consider T21. This is the general process. So that means this task can be performed in a parallel manner. So that is the basic intention of the pipelining, right? So let us see, move on to the next one. When we are using the, when it is implemented. Obviously, if we are defining the pipelining is nothing but an implementation technique which performs the multiple tasks in a overlapping manner. Then when we are using pipelining, there is a basic question obviously each and every person, right? So the basic when it is implemented means it can be implemented when a task can be divided into multiple tasks or maybe subtasks which can be performed independently. Instead of reducing the clock frequency in the pipeline approach, the delay through the critical path of the functional unit is reduced such that the supply voltage can be reduced to the minimum power. Supply voltage can be reduced to minimize the power. Basically, in case of the parallel processing approach, we are reducing the both frequency as well as supply voltage in order to achieve the minimum power dissipation, right? But in case of the pipelining concepts, instead of reducing the clock frequency in a pipeline approach, we will delay through the critical path for the functional unit is reduced. That means if you are reducing the delay means obviously the supply voltage such that the supply voltage can be reduced to minimize the power also. So that is a basic intention of the pipelining concept. So let's move on to the next one. Here an example of consider the pipeline realization for the 16-bit adder using a two-stage pipeline process that can be shown in the figure 7. We will see in the later. In this realization, instead of realizing the 16-bit addition, we can perform with the help of a 8-bit adders. So previously, in case of the parallel processing, we are performing the addition with the help of a 16-bit adders. But in case of the pipelining process, that 16-bit adder can be performed with the help of a 8-bit adders, right? Let us see so as well as in case of the 8-bit adder operation, the operating of the clock frequency may be 100 Hz, so that can be reduced the power supply voltage by a V reference. That means, so supply voltage can be reduced to the V reference, that is nothing but V references by 2. It may be noted that in this realization, the area of the penalty can be much less than the parallel implementation. That means parallel implementation. That means if the area of the device is decreases in case of the pipelining process means that capacitance is also decreases. If the capacitance value is decreases, what happens is that Let it be see the in the next slide. So generally the C pipelining, that means in case of the pipelining, the overall capacitance value is equal to 1.15 times that of the C reference value. If you are substituting that value in the next on the dynamic power dissipation equation, we will get around the value is equal to 0.28 of x. The C reference value is equal to 1.1 times set of the C reference value, right? If you are substituting that value in the dynamic power equation, we will get the power dissipation around 0.28x only. So this is the structure of the parallel pipelining. So this is nothing but overall 16-bit register. Generally, these 16-bit registers can be implemented with the help of a two 8-bit registers. The first 8-bit adder performs the first 8 bits of the 16-bit data. So the remaining 8 bit of data can be performed by the, this is a 8-bit data, this is also 8-bit data. The remaining 8-bit data performed by the second 8-bit adder. So therefore, the overall performance of the circuit is also increased, as well as the area of the device is also decreases. Why? Because previously the same 16-bit operation can be performed with the help of a two 16-bit registers. If you are taking a two 16-bit registers, means that obviously we are duplicating the number of counts. But in case of the pipelining process, we are taking only one 16-bit register. That 16-bit registers also can be performed with the help of a two 8-bit adders. Therefore, the area of the device is decreases because of the number of components is also decreases. That is the basic interest of the pipelining. So let us see, the area is also decreased to the 1.15 and performance is also 1x. So generally in case of the parallel processing, this is around the area is also 2.2 times that of the, as well as it is also 2.2, and all these values are in terms of, and the area and both power dissipation is also 2.2 of the original value in case of the parallel processing. But if you go for the pipelining approaching, the power is also reduced to, area is reduced to 1.15 in case of the supply voltage scaling, as well as power is reduced to 0.28 for supply voltage technique, the supply voltage scaling technique, as well as performance is also same value. So let us see, in case of the area is nothing but 1.5, 2.30x for power dissipation, throughput is nothing but, so the performance is very increases in case of the pipelining. But if you are as well as the power dissipation is also increases. So for that purpose, we need to maintain a minimum power is nothing but 0.28. So the overall conclusion, this one is nothing but the parallel processing is used to reduce the power dissipation, pipelining is used to improve the performance. If you are those two combined, the overall circuit is also better and better for the low power applications, right? So this is our C reference. If you are substituting that value, that can be shown in the previous table also. Let us move on to the combining the parallelism with pipelining. So generally it is an extension, obviously extension of those two approaches, whatever we discussed in the previous videos also. Parallelism and pipelining. Here the more than one parallel structure is used to each structure is pipeline. So let us see the 16-bit adder can be performed by the combining the both pipelining and parallel processing approach. The two pipeline 16-bit adders have been used in a parallel manner. Therefore, the power supply and frequency of the operations also reduced to achieve the substantially to reduce the overall power dissipation, right? So this is a formula for parallel C parallel pipeline and C parallel. So the PAR PAP means that values are used in case of the parallel and pipelining approaching process. So let us move on to the next one. In case of this process, both if you are combining both the parallelism and pipelining approaches, one of the most effective advantage is nothing but the overall capacitance value is reached to the 2.5 times of the C reference value. Actually, in case of the parallelism, that C reference value is 2.2x, right? But if you go for the pipelining, it is 1.15x. But if you go for the combination of the both pipelining as well as parallelism concept, that value is equal to 2.5 times that of the C reference value. If you are substituting that value, as well as one important point you have to notice is nothing but one important point is nothing but the supply voltage can be more aggressively reduced to about a 1/4 of the original value. Because of the C reference value is increased means the F reference is also decreases. Because of the generally we know that P is equal to CVF, right? So if you are observe this one, C and F, both the supply voltage and supply voltage and capacitance both are inversely proportional. That means if the capacitance value is increases means the supply voltage is also decreases, right? But if here V square is nothing but it is a 1/4 of the value. Therefore 1/4 times that of the C, 1/4 of the, that means 1/4 of the overall V reference value. Therefore, if the supply voltage decreases means that obviously the frequency is also decreases because of frequency and supply voltage, that is also linearly dependent, right? That is also discussed in the previous slide. F is directly proportional to VDD into 1 minus VD by VDD whole square format. One equation will be there. Therefore, by getting these two values, that means C value is nothing but around 2.5 C reference, and the supply voltage is also 1/4 of the original value. Therefore, if you are substituting those two values in this equation, we will get the overall power dissipation in case of the both parallel and pipelining. By combining those two, we will get a power dissipation of around 0.1125. This shows the overall performance that can be depicted in the diagram what we are getting in the previous. Also, let us move on to the next one. Here voltage scaling for using for a high level. So for automatic systems, the digital systems and all those things we will discuss in the later sessions. So this is an example for the parallelism and pipelining for the corresponding diagram. So this shows that where the overall performance is also reduced to 0.1125. That means the power is decreases to 0.1125, but area maintains at 2.5 times that of the original value, but throughput is also 1x. So this is the overall regarding the pipelining concept, how we are applying the concept to the parallel processing as well as the pipelining for the real-time process. That is nothing but actually it is nothing but a IIR filter of the order 1 actually. So where VDD is equal 5 volts and throughput 1 value and power value is also 1x. So this is nothing but directed acyclic graph is the representation for the corresponding one. So this is the overall pipelining and parallel processing, how the pipelining and parallel processing are used for the low power applications. This is the basic idea behind this one. So thank you for watching GMK tutorials. Thank you guys. Thank you.